Good morning, students. Welcome to the e-learning platform, an initiative launched by the Department of Collegiate Education. In today's video class, let us learn about body symmetry. In this chapter, the learning objectives include understanding the different types of symmetry and the advantage it confers. And by the end of the chapter, you'll be able to understand the nature of the body symmetry and in a position to identify the different kinds of symmetry that is seen in various life forms. Moving on to the introduction, what is body symmetry? Symmetry in biology is the balanced distribution of duplicate body parts or shapes within the body of an organism. That is, suppose this butterfly is cut along this particular plane. We get exactly two equal halves because the body organs are distributed in such a way that they are balanced and they are giving rise to two equal halves if cut in the center. So this is what we refer to as body symmetry. In nature, symmetry is always approximate. That is, it is not an absolute concept. There's nothing like 100% symmetrical. It's mostly symmetry, roughly symmetrical. Therefore, we say it is approximate. Symmetry creates a class of patterns in nature where the near repetition of the pattern element is by reflection or rotation. Going back to the same butterfly example, suppose I'm cutting and I'm placing a mirror right next to the axis or the plane through which I have cut. I'm going to, whatever the mirror image I can see in the mirror is what is actually the one which is on the other side. So they're exactly mirror copies or equal halves. So therefore we say the repetition of pattern element is by virtue of reflection. The body plans of most multicellular organisms exhibit some form of symmetry. It could be radial, bilateral, or even spherical. Whereas a small minority, that is mostly sponges, they exhibit no symmetry. That is, they are asymmetric in nature. Because of their irregularity in size, it is not possible to have symmetry. Therefore, we say it is said to be asymmetric in nature. Symmetry was once important in animal taxonomy. The radiata, animals with radial symmetry, formed one of the four branches of George Cuvier's classification of animal kingdom. The five main types of symmetry seen in animals are asymmetrical symmetry, spherical symmetry, radial symmetry, bilateral symmetry, and biradial symmetry. In asymmetrical symmetry, I've quoted the example of sponges, where symmetry is not possible because of its irregularity in shape. No matter in which plane we cut it, we still don't get two equal halves. So therefore, they're said to be asymmetric in nature. Moving on to spherical symmetry. Here, I've taken the example of protists. That is the class which includes volvox, thalassocola. Here, it is mostly like a ball. And if at all, if the plane is passing through the center of that ball, no matter in which direction it is passing through, we still get equal halves. Therefore, it is called as spherical symmetry. Whereas in radial symmetry, here also we get equal halves in many planes provided it is a cylindrical form. That is, in spherical we can take globe or ball as an example, whereas for understanding radial symmetry we can take circle as an example. So in that circle, if at all the plane is passing through the center, no matter in which direction it passes, it is still equal half. That is, it is still yielding equal half. So that is what we refer to as radial symmetry. And the fourth one is bilateral symmetry. That is, along one single plane only it leads to or it yields two equal halves. Best example is human body also. When cut across, we are getting two equal halves in one particular plane only. And the last one is biradial symmetry. Biradial symmetry is a combination of both radial as well as bilateral symmetry, and it is seen in cnidarians. So let us learn them in detail. Asymmetrical symmetry. In some animals, there are no body axis and there's also no plane of symmetry. Hence, the animals are called asymmetrical. The amoeboid forms, that is amoeba, and many sponges with irregular growth pattern of body cannot be divided into two equal halves. Here in the diagram, we are seeing amoeba. It is not having any definite shape and the shape keeps fluctuating. Here, no matter in which plane I'm trying to cut across, I still don't get equal halves. That is the reason why we say it is asymmetrical in nature. The other example includes sponges. Because of their irregular growth pattern, even in sponges also, the symmetry can't be obtained. Therefore, they are considered as asymmetrical in nature. Second one is spherical symmetry. In spherical symmetry, the shape of the body is spherical and it does not have any axis. It basically lacks axis. The body can be divided into two equal halves in any plane that runs through the organism center. So, whatever the plane here is, no matter in which direction, it has to compulsorily pass through the center of the organism in order to get two equal halves. In asymmetrical symmetry and spherical symmetry, there is no polarity. And the best example is radiolarian protozoa. The third type is radial symmetry. In radial symmetry, the body can be divided into two roughly equal halves. Why I'm saying roughly equal is because the very beginning I told you the very concept of symmetry is approximate. So therefore here in radial symmetry the body can be divided into two roughly equal halves by any one of the many vertical planes passing through the central axis like the spokes of a wheel. The animals which exhibit primarily radial symmetry are cylindrical in form and the similar parts of the body are arranged equally around the axis. The axis extends from the center of the mouth to the center of the aboral side. So where the mouth is located, that side is referred to as oral side and the side that is away from the mouth is what is known as aboral side. Here, best example is starfish and cylindrids like hydra, sea anemone. They are all cylindrical forms and they have a mouth which actually forms the center and it can be cut across in different planes but along the center of the body again. So this is what is known as radial symmetry. The radial symmetry is seen among the sessile and sedentary animals such as in some sponges, hydroids, anthozoan polyps, medusae and sea stars. So these are the examples of animals with radial symmetry. Special forms of radial symmetry are observed in different groups of animals, that is tetramerous symmetry, pentamerous symmetry, that is what we saw in starfish. Because of its 5 arms, it exhibits pentamerous symmetry, hexamerous symmetry, octomerous symmetry. The animals with radial symmetry do not have anterior and posterior sides or dorsal and ventral surfaces. They have a mouth-bearing oral side and the side away from the mouth called as the aboral side. The next symmetry is bilateral symmetry. In bilateral symmetry, the body parts are arranged in such a way that the animal is divisible into roughly mirror image halves through one plane, that is mostly the mid-sagittal plane. This plane passes through the axis of the body to separate the two halves which are referred to as the right and the left half. So when the body is cut into two halves, we are getting exactly two halves, that is right and the left half. The animals which exhibit bilateral symmetry are called as bilateria. Bilaterally symmetrical animals include acoelomates, pseudocoelomates, eucoelomates among invertebrates and both lower chordates as well as vertebrates and higher animals. Moving on to the last symmetry, that is biradial symmetry. Here the body of animals which exhibits biradial symmetry represents a combination of both radial and bilateral. So if both radial and bilateral are put together, we get biradial symmetry. The organs are arranged radially and the body can be divided into two by a mid-longitudinal plane. Example include Ctenophora. Moving on to the advantages of symmetry. Bilateral symmetry is associated with the term cephalization, that is the specialization of the anterior end of the body to form the head, where the nervous tissue, sense organs, and feeding organs are concentrated. So therefore, it is associated with cephalization, that is the head formation. And other advantage of this symmetry is the streamlining of the body, development of different organs in different body regions, and more efficient unidirectional movement. Radial symmetry also helps the animal for collecting food, and it is helping in defense. To summarize quickly, biological symmetry can be thought of as a balanced distribution of duplicate body parts or shapes within the body of an organism, and the different types include asymmetrical, spherical, radial, biradial, and bilateral symmetry. Yes, so let's quickly solve these multiple choice questions. The first question is, which among the following is an example for asymmetrical body symmetry? That is, the ones which do not have any symmetry. The options given are euglena, amoeba, bacteria, and butterfly. In the very first slide, we learned that butterfly is having bilateral symmetry. That is, when cut along the central axis of plane, we are getting two equal halves. So therefore, it is having bilateral symmetry. So butterfly can't be the answer. Even bacteria can be cut along different planes to get almost two equal halves. So therefore, even bacteria can't be an answer. Euglena also, when cut along the central axis, we are getting two halves. So therefore, euglena also can't be an answer. And the obvious answer is amoeba, because amoeba is basically having no definite shape, and therefore a symmetry is not possible. So amoeba is an example for asymmetrical body symmetry. Apart from amoeba, sponges are also an example for asymmetrical body symmetry. Second question. Consider the following statements about spherical symmetry, and we are supposed to choose the correct statement. So we have to analyze whether the statement given is right or wrong, true or false. The shape of the body is spherical. We are speaking about spherical symmetry, and the shape of the body is spherical. So yes, let's assume this is true. It lacks any axis. Yes, in the very beginning we learned that spherical symmetry, there is no definite axis. The body can be divided into two identical halves in any plane that runs through the organism's center. Yes, only if the planes are passing through the organism center, we tend to get two equal halves or identical halves. And the example, it is seen in radiolarian protozoa. Yes, radiolarian protozoa is an example for spherical symmetry. So all the four options are correct. So the obvious answer is 1, 2, 3, and 4, all of the above. Moving on to the next question. We are supposed to identify the type of symmetry. In this type of symmetry, the body can be divided into two roughly equal halves by any one of many vertical planes passing through the central axis like the spokes of a wheel. So whenever you come across the word spokes of a wheel, please remember a circle. Therefore, the answer is radial symmetry. In radial symmetry, it is like a circle, and all the planes have to pass through the center of the organism. So therefore, it looks like the spokes of a wheel. Example for radial symmetry include hydra and also starfish. They are all examples for radial symmetry. Sea anemone, even that is also an example for radial symmetry. The next question. Consider the following statements, and we have to identify the type of body symmetry. The first statement says, the body of animals exhibiting this type of symmetry represents a combination of both radial and bilateral symmetry. So here they're saying that it is having combination of both radial and bilateral. So from the very option we can guess what is the kind of symmetry. And the second statement is, ctenophores exhibit this kind of symmetry. Yes, the answer is biradial symmetry, and the example of biradial symmetry is ctenophora. So ctenophores exhibit this kind of symmetry. It's a very straight question. And moving on to the last question, consider the following statements about bilateral symmetry. So we have two statements and we have to choose the correct statement. In bilateral symmetry, the body parts are arranged in such a way that the animal is divisible into roughly mirror image halves through one plane. So only through one plane it can divide into two equal halves. Yes, that is, say for example, human beings. When cut across only one plane, we are getting two equal halves. Suppose I am cutting it this way. Do I get equal half? No. So it's along only one plane we are getting mirror image. The animals which exhibit bilateral symmetry are called as bilateria. This is also a correct statement. So the obvious answer is both 1 and 2. I hope this video lesson was of use to you and have a great day. Thank you for your patience.